class we are going to discuss one case study video which is going to be played by third year students. The topic of this case study is electrosurgical machine. So let's have a discussion now. Shall we start the discussion now?
Yes, ma'am.
Yes. What is the title of today's topic?
Electrosurgical.
Can anyone tell us what is mean by electrosurgical machine, that is ESU?
So the ESU electrosurgical unit is a medical device which is used in surgeries to cut the tissues and control bleeding by using a high frequency current. So how it works is it works by delivering a radio frequency energy by using an active electrode.
What is the frequency range which is being used for cutting and coagulation? That is especially in ESU machine.
So a high frequency range of 300 to 500 kilohertz is used. A high frequency is used because low frequencies may cause or stimulate the nerves and muscles, and it may cause pain.
It's a very good explanation why we are using high frequency current in especially ESU unit. Then we will move on to what are the different modes which is being used in ESU unit. Can anyone explain?
Yeah, there's two modes in electrosurgical units. Firstly, we are going to see about cut is the electrosurgical unit delivers a high frequency current. It will going to high frequency make tissues. Electrosurgical unit delivers a high frequency range which is equal to above 100 degrees Celsius. It is cause tissue vaporize. It can break cell membrane and it cause cell tissue cutting. Here we are using waveform, sine waveform and continuous waveform. Then coming to coagulating, it is the procedure to make the tissues clot and blood vessels. Then it is going to dehydrate and denature the protein of tissues. Here we are using pulse wave.
What are the other modes?
So yeah, ma'am, actually with that we have two modes. One is desiccation and another is pulverization. So desiccation is nothing but it is a thing in medical field where we used to point out for drying. Usually we remove the moisture content from the particular place. For example, if we get a wound, we will remove the moistureness to avoid bacteria. And pulverization is another process where we use the electric current, a small current in tissues to remove the particular part.
It's very good. Now just we will move on to the techniques. I think we have two techniques which are in ESU machine. What are those two techniques?
So there is two techniques. One is monopolar and another one is bipolar. In monopolar, from the generator which generates a high frequency current, the current is taken into the patient's body, and through the grounding pad, which is the reference electrode, we take it back to the generator. So this is like one way. Only one active electrode is used in monopolar, which is a traditional method. In here, we don't have another electrode to send back the current. And the next one is bipolar. Over here, the current, same procedure. The current from the generator is passed to the patient, and here we use a forcep, which is a couple of electrodes. So one electrode will send the current to the patient body, and the electrode which is next to it will collect back the current and send it back to the generator. This way we can reduce the risks of burn due to excess electrical current on the patient's body. So these are the two techniques, and the most used one in nowadays is bipolar because it's more effective than the monopolar.
Yes, now I have one question. Why patient electrode is recommended in a unipolar method and why it is not be used in bipolar? In what way it is important?
So actually the patient electrode or the grounding pad, it ensures that whatever current we send is closed. Such a way there is no dissipation of current throughout the body. So we are going to send a current or any kind of impulse to one particular side, and we take the excess current back to the generator, ensuring the patient safety.
Can you relate with any real-time incident or example, like case study?
In 2007, there was a patient who were suffering from third-degree burns. So this leaded because of the improper placement of the patient electrode. The surgery went right, but unfortunately the patient had severe burns due to the staff not being alert about the placing of patient electrodes. So this way we have to be aware about the grounding methods.
Okay, can any other people give some suggestion how can we ensure the patient safety, especially in ESU machine?
Yeah, ma'am, I would like to answer that. First of all, for patient safety, we should ensure the proper grounding, and also we should ensure how the electrode should be placed, and also capacitive coupling. I would like to add one story. It is a real-time story that happened. There was a patient going on with gallbladder surgery, and capacitive coupling was happening. So current was leaking through some metal with the surgeon. The surgeon was not aware of that. So the patient had a severe injury because of that.
Yes, yes. Then from US point of view, what is the work of biomedical engineer, especially in the maintaining aspects of ESU? What is the role of biomedical engineer?
We should have a proper development of the instrument such a way there is no harm to the patient.
And one more thing is,
We should be aware of the electrical currents. We
and
should
leakage
make
of
sure-
electric currents, electrical safety, and one more thing is proper maintenance and calibration of medical device. Because ESU is such a machine where they are dealing with high frequency current, so there are high chance, high tendency for the patient to get shock. So as being a biomedical engineer, our role is playing very important. Like in order to provide improve the quality of life of patient by ensuring or avoiding patient safety. Yes, then we will conclude this group discussion with the application. So can anyone say what is the application of this ESU, like where it can be used?
Yeah, there are so many applications on that. Generally, we are using in surgeries. When we open up surgery, we have help of electrosurgical units, cutting tissues and coagulating. Then gynecology, urology, ENT to stop the bleeding. Then robotic surgery. There are so many applications on that. Mainly, there are the advantage in electrosurgical units, which is minimizing the bleeding, perfect tissue cutting, and sterile, no direct contact is there.
But I have a doubt, like why bipolar is more convenient than monopolar?
So I think bipolar is used for precise surgeries and it ensures safety, because once in a cosmetic surgery unit there was a fire accident in the operation theatre. It was due to using an alcohol-based prep solution. It was not fully evaporated and the active electrode ignited the vapors and causing burnings in patients. So I think bipolar ESU is used for precise surgeries and to ensure safety, because once in a cosmetic surgery unit, the monopolar ESU caused a fire accident in the operation theatre because the alcohol-based prep solution was not fully evaporated and the active electrode ignited the vapors. It caused the burns in the patients and damage to the instruments. So bipolar is considered more than the monopolar ESUs.
Can anyone conclude this group discussion?
So this group discussion was really eye-opening session because we learned about a lot of things, modes, techniques, what is USU and how is it applications in biomedical instruments. And as a biomedical engineer, it was a good discussion.